Hello everyone, my name is Ido Ben-Arzi from Tel Aviv University, and I'm glad to present to you my research about how people make decisions according to irrelevant things. So to present to you this topic of outcome-irrelevant learning, I would like to kick off with a nice example by Professor Yael Niv. Imagine the following situation, in which you crossed the street and almost got hit by a car, and now you have to learn from that experience. A relevant thing to learn about in this occasion may very plausibly be the speed the car was driving at. But we can confidently assume that the leg with which you first stepped into the road is irrelevant for the unpleasant outcome. However, to keep this representation in mind, constantly discriminating between relevant or irrelevant features of the environment is not such a trivial task, and previous work in our lab showed this. We can schematically represent our previous example as having to distinguish between outcome-relevant features on which we should learn and irrelevant features which we should neglect in our learning and decision process. The hypothesis we wanted to test in this project is whether this representation is related to working memory capacity and load. As you can see, individual parameters for key response learning were correlated with individual differences in working memory capacity. On the right, you can see the posterior distribution for the reward and capacity interaction effect. I will now give a more detailed description of the research. So the basis of our research resides in the following article, which showed that people assign value also to outcome-irrelevant features of the environment. In the article's discussion, the authors speculated that task representations are actively held in working memory, and that when working memory resources are low or more demanding, then differentiating between those features would be harder. So that's the basis for our hypothesis for this project. The first hypothesis meant to replicate former findings. The second one refers to the more demanding part, implying that manipulating working memory resources while doing a choice task will cause higher outcome-irrelevant learning. Finally, the third one refers to the more low idea, thinking that individual differences in working memory will affect outcome-irrelevant learning. Here, you can see the sequence of the choice task used in the experiment. Participants were asked to choose between two cards and then saw whether they got a reward or not. After that, participants saw a pair of two different cards and had to choose again between the right and the left one. They were also told and tested for their understanding that only card identity and not the key response or location are related to the probability of gaining a reward. What we see on the graph on the left is that although participants were fully aware that the key responses were irrelevant for their winning chances, they repeated the same response key in the second offer more often if the first offer was rewarded rather than unrewarded. To test the second hypothesis, we used the dual tap procedure, in which participants completed the choice task while doing a working memory task. The blocks differed in how much squares participants had to maintain in their working memory while doing the choice task. It could be 4, 1, or 0, in which the memory square was in a fixed color. We were unable to find any differences between the three conditions. Finally, participants were also evaluated for individual differences in working memory capacity, and those were correlated for their tendency to stay with the same response key after obtaining a reward. The aim of our study was to examine the relation of value assignment to irrelevant features and working memory resources. We were unable to find an effect for the increasing of load over working memory by inducing a dual task procedure. However, we did find a correlation between individual differences in working memory abilities and our learning estimates. The limitations of this new finding lies in the correlative nature of it, and it can very much be a result of a different mechanism other than lack of ability to hold representations while learning. However, this finding joins these from attention literature, which show a similar tendency of low working memory individuals to attend to irrelevant stimuli. We speculate that low working memory individuals are struggling to inhibit learning for irrelevant features of the task. We think this struggle in inhibition may be due to a difficulty in representing correctly the task model in working memory. The results of the current study raise some interesting questions. For example, how could it be that the manipulation of working memory load did not affect learning for the keys, although working memory capacity was correlated to it? We think a possible explanation could be that the current dual task method was unable to effectively load participants' working memory as they were doing the cards task. Possible mechanisms for this was suggested by Stokes et al., who offered that information from the main task may be maintained on a low neural activity level without interfering the secondary task. Conversely, it could be that high working memory individuals understood and maintained the task instructions better than their counterparts. Finally, it is possible the general lower motivation was what held those individuals back in both the working memory and cards task. This research was funded by the Israeli Science Foundation and supervised by Dr. Nitzan Shachar and Professor Roy Luria. Thank you for listening.